Welcome everyone. In this video we will discuss encoders and decoders. An encoder is a combinational circuit which converts an active input signal into a coded output signal. Figure 1 shows the block diagram of an encoder having n input lines and m output lines. Only one of the input line is active at a time, and the internal logic within the encoder converts this active input to a coded binary output with m bits. One of the most commonly used input device for a digital system is a set of 10 switches, one for each numeral. These switches generate 1 or 0 logic levels in response to turning them on or off. When we feed a particular number to the digital circuit in Bcd, then the switch corresponding to that number is pressed. There is an IC which is available in the encoder to perform this function. Let us consider a decimal to Bcd encoder as shown in the figure 2. This is the decimal to Bcd encoder. These are the switches and these are the outputs of the OR gate. From this circuit of decimal to Bcd encoder, we see that if we press the switch 0, then we find that all the OR gates are inactive, and so the output by B4, B3, B2, B1 is 0, 0, 0, 0, which is the Bcd equivalent of the decimal 0. Now if we press the switch 1, then we find that only the OR gate 1 is active, and therefore the output B4, B3, B2, B1 is 0, 0, 0, 1, which is the Bcd equivalent of the decimal 1. In a similar manner, if we will press the switch 7, then the OR gates 3, 2 and 1 are active. So the output B4, B3, B2, B1 is 0, 1, 1, 1, which is again the Bcd equivalent of the decimal digit 7. We can also draw the truth table for this decimal to Bcd encoder as shown in the figure 3. This is the truth table of the decimal to Bcd encoder. From the truth table we find that these are the inputs and these are the outputs. There are 10 switches which has been represented by the numeral 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 9, and the outputs are the outputs of the 4 OR gates. If we press the switch 1, then all the OR gates are inactive, so the output B4, B3, B2, B1 is 0, 0, 0, 0, which is the decimal equivalent of 0. Similarly, if we press the switch 4, then we find that only the OR gate 3 is active, and so the output by the 4 OR gates will be 0, 1, 0, 0, which is again the Bcd equivalent of the decimal 4. Similarly, if we press the switch 8, then only the OR gate 4 is active and all the OR gates are inactive. So the output B4, B3, B2, B1 will be 1, 0, 0, 0, which is again that is Bcd equivalent of the decimal 8. In this way we can draw the truth table for decimal to Bcd encoder. Now let us see what is a decoder. A decoder is also a combinational circuit. A decoder decodes the coded input signal into an active output signal. A decoder is similar to a demultiplexer with the only exception that it has no data inputs. The input for a decoder are the control signals. The block diagram of a decoder is shown in the figure 4. Now we will consider a decoder having 4 input lines and 16 output lines. Since only one of the 16 lines is high at a time, therefore this decoder is also called 1 of 16 decoder, and the circuit diagram of the 1 of 16 decoder is shown in the figure. This is the circuit diagram of 1 of 16 decoder. From this circuit diagram, we find that when the value of A, B, C, D is 0, 0, 0, 0, then only the AND gate with the output Z0 is high. Now if A, B, C, D is 0, 1, 0, 1, then only the AND gate with the output Z5 has all the inputs high, and so only the output of Z5 is high. Now let us consider the case when the value of ABCD is 1, 1, 1, 1. In that case, we find that only the AND gate with the output Z15 has all the inputs high, and so the output of Z15 is high. After considering all the values from 0, 0, 0, 0 to ABCD is equal to 1, 1, 1, 1, we find that the subscript of the high output gives the decimal equivalent of the binary number ABCD. For this reason, this circuit is also called binary to decimal decoder. I hope this topic is clear to all of you. This is the circuit of 1 of 16 decoder.